Thank you for being here. Hope you have been a good day so far. We still have 1.5 days, so hold there. We get there. So, if I may ask, who didn't went to the session of the 100 minutes on Tuesday? Cool. So, the idea is to, I will recap on the slide part and then jump on the demos. And on the demos, I will be doing new demos. So for people that went to the session, they will see still new stuff, okay? And depending on the time, we may or not repeat one of the other demos, because as we have more people that didn't went there. I'm not asking for feedback right now, as you may imagine, but I want to remind that feedback is important not only for the speakers, but SQL Bits is giving money to charity. So for each feedback that you provide, you can select one of the two charities and in that way help in some form. You don't spend any money, you spend 2 minutes, so do your thing, please. And by the way, so this demo or this session was not on the schedule as the beginning of the conference, which means that these will take you to the 100-minute session, but I think you can provide feedback there anyway. So in the end, it will be the same. Okay, so let's do a recap. What are the T-SQL query tuning expectations that I see on other people? Whenever I was traveling to here, I came from Lisbon, Portugal, and I was on the queue to do the check-in, and I said to the lady, hey, I don't have a slow query. And the lady said, okay, come on in, don't touch it, just go board to your plane. And later on the plane, I call one of the ladies and say, sorry, I have an emergency because I found a slow query. And the lady, very helpful, said, well, why don't you create an index on each column that you have on your tables? That most probably will help. And the query was still slow. I followed the advice and it didn't work. And the other suggestion, I don't know if you can relate with this, whenever people say, well, more CPUs, more memory, everything will be fine. But I think until you get to that point, because it can happen that we get to that point and we are just burning money until that. And think about cloud. Who is managing and running stuff in clouds? Or, yeah, so the amount of money that you may pay to have, or it's easier to go on the slides and say more power, more CPUs, and more credit card limit. So the captain came and said, well, then if SQL Server is not working for you, why don't you change to another one? And I had this crazy idea about rewriting the queries before going there. And yeah, the captain was not very happy, but I'm glad he asked who I am. My name is Claudio Silva. My pronouns are him, and I work for Data Masterminds. My daily work is performance tuning. I live inside SSMS, seeing ugly code and try to make things go faster. When I'm not doing that, I'm working with some automation and working on the open source projects like DBA tools and DBA checks. So let's do a reality check about query tuning. We have a lot of variables that can change the behavior that our query and the engine will try to compile a plan and to make things run. And that goes not only with the CPU, memory, and disks, but then if it is physical, virtual, even the configurations outside of SQL Server on the machine level, and if it's running on some cloud, if some of the features are already available or not. But then we also have the SQL Server edition, because if you are running a standard edition, there are a good number of features that you cannot use out of the box. And the instance configurations, how much memory I have configured. What are my cost thresholds for parallelism, which is a number that says when I compile a query, I have a cost. If that cost for that query is higher than this value, the engine will try to compile a new plan using parallelism. And if the outcome of that make the costs lower than the previous one, then it says it has less cost, then let's try to use the parallel one. And on that also come to play the degree of parallelism. So how many threads an operator can use to fetch data in parallel or not. But we still have database. And database we have compatibility level. And compatibility level, different versions have different things. And we also have scoped configurations. So nowadays we can change a lot of these configurations per database. As an example, you can change the degree of parallelism per database, meaning that nowadays you can have like a SharePoint database that needs a max.1 running on the same server that you has 4, 8, 16 CPUs, because we can still say this database runs just on a single core. And of course, the workload type. So this is one important thing. As a consultant, when I jump on from the plane and go on the client, most of the times, as the first interaction, I don't know the data, how the data is distributed. And this is important to have a talk with the business or with the people that know the data, so we can see, depending on the distribution of the data, we may need to think differently and to have different approach. And that's why this session is not about creating indexes to make queries go faster, but rather they can be already there, but rewriting the T-SQL in a different manner, we can help the engine to do the work faster for us. Okay, let's jump then on the demos. The environment. I'm using a SQL Server container, so you can see the little penguin there. So this is a Linux Ubuntu version with SQL Server 2022. And here, I'm using the SQL Server Developer Edition. So you can see here the Developer Edition, and you can see here where it's running. And the database I will be using is a Stack Overflow database that has more or less 10 gigabytes that you can get if you use Docker to have containers. You can download the SQL Server image or the Docker container image that contains SQL Server with some databases from the DBA Tools repository. So if you work with DBA Tools and you want to test something, you can just download the image, you can test your migrations, you can test the commands that you want, and I'm leveraging on those containers to have this database. I'm also using, and this is also an important bit, SSMS 19 something. More recent one. So it's not 20 yet. I didn't dare to install the 20 before doing all my sessions. Be aware that version 20 is already out and have some security enhancements. So take a look on that. But here, the main thing is that since the version 19, we can see like partial times on the execution plan. And that is also together with other features that come with 2022. Okay, if you are connected to a 2022 version, we can get a little bit more information. That said, my configurations are these ones. So I have a cost threshold for parallelism of 25, the degree of parallelism 4, and the 4 gigabytes for the max server memory. And just to show what I was saying, nowadays we have like 35 scoped database configurations, which in this case, none of them are changed. So I'm using like the default. If you migrate a database from an old version to this version, you get this by default. But just for you to be aware that if you change some of this stuff, you may change the behavior of the engine and to create a plan, and that can have also different outcomes. So on the last session, I did all the demos through the 1 to 5 plus the 7, and I let the 6 out of purpose for today, and today we will try to go 6, 8, 9, and 10. I did a 20-minute session about why data types still matter. Okay, here we can see 1 or 2 examples that I talked there. That was just a more slideshow session with some screenshots, but we will see here why the data types matter and how that influence, how that impacts the performance of our queries. So let's start to create here a table with some values, and I will turn on my statistics time IO and get my actual execution plan whenever I run, and I will run this query. So I run the query, I have results, but I also have a quite big difference here compared with this one. So for those that doesn't know, logical reads, each single unit of logical read is a 1/8 KB page that is being read from memory, okay? So the more that you have here, the more you need to read from memory to fulfill and to accomplish your query. So why do you think seeing this query, so I can say this query is exactly the same, okay? So what do you think is happening here? Why, and let me show here, why we have an index scan on the first one, and we have an index seek on the second one. Any guesses? Yeah. Sorry? Yeah. So the answer was the variable definitions were different. Correct. So this is the common scenario of the implicit conversion. Okay, so this means that I have created a table that has this name, a T-SQL name column as a varchar, yes, a varchar, so a known Unicode data type. But if you see here, I'm declaring this one as a Unicode and this one non-Unicode. And this for SQL Server will be like, okay, I know in my table I have carrots. I know that my variable are cabbage. How do I compare those? And it needs to go to the table, convert all the carrots in cabbage, and after that, doing the check. And that's why we had 38 logical reads, which is in this case the entire index, and then you can do the comparison. So this is a regular, normal, implicit conversion. It can also happen with numbers when they are being passed as strings. And you can see maybe on Entity Framework, Hibernate, and all RMs that do these things. So let's see another example about partitioning tables. Who does or who uses partitioning? Okay, few hands up. So first of all, partitioning is not a performance feature. Okay, it helps with your data movements, with your ETL processes to purge data and so on, but it's not and should not be used as a performance feature. However, if we really need and we have a partitioning in place, we may be able to leverage on partition elimination. So those ones that raised their hand to using partitioning, do you know what is partition elimination? Have you heard? Okay. A couple of people not. So partition elimination is the ability that the engine has to say, imagine I have a table with 360 partitions because it's a whole year, and I do a search and I want to find data on a specific day. What would you expect? That the engine is smart enough to go to one partition, the partition that match that condition, and read the data, right? Let's see what happens. So I created a partition table, which has these values, and here I'm showing just the partition number, just to show that we have like 5 different, or 4 different values, 5 different partitions. Now, let me turn on this again, and let's see here. what happens if I run this query? Then I'm saying that my call 1 should be bigger than 1,500. If we come here, we see that our table is partitioned and that our actual partition count was 1. Another way to see this is going here to the properties and having here. So what this is telling me is that, hey, I touched one partition, and this partition was the partition number 5. So partition elimination is happening here. Now, what happens if I say that I want to do bigger or equal to that 1,500? It now says that I touched 2. Why? Because my boundary on one of the partitions is the 1,500. So we still get partition elimination. So what happens if I do the same select on a known partitioned table? I don't have information about being partitioned or not, and I see that I got a table scan. Okay? Because no partitions, engine doesn't know, need to scan the entire table to be able to fulfill the query. Okay, now let's read the data from partitions 45, 4 and 5. If I'm reading from 4 and 5, what the heck happened here? So SQL Server is telling me, yeah, your query is here, your data is here. I had to scan and to touch on 5 partitions. But come on, we just saw an example where I did bigger or equal to 1,500, and it just touched 2 partitions. Why now it's telling me I'm touching 5? Any guesses? Sorry? Big int. Good guess. So partition elimination is very sensitive, and which makes sense, because the engine needs to take safe decisions to say, I will not touch on the other partitions, because I know that the data that you are telling me to take a look is exactly this one. Okay? So in this case, just to show here how it, in this case, yeah. So let's create here a slightly different partition table, which are related with dates. So in this case, we will be partitioning based on dates. So the same principle, a table with a bunch of records. The table is partitioned by the event date column. And what we're going to see is what happened when we query some data, if it wants to finish. Okay. So here we have the partition number. And just to show that we have some distribution, some data all around. So again, what happens if I do a select, getting my event date, and if I include here, so what happened here? What it says is, actually, I touched on 3 partitions, and those partitions were 3, 4, and 5. Okay? This is how we can read how many partitions in this case we are touching. But now let me run these 2, which doesn't return any result because there is no match on the data. But if we come here, we see that we have 5 partition touch. So in this case, we know that this is the entire table. It went and touched on each one of these partitions. However, I have here the other query, which is with the same filter. And that one just says, nope, I just touched on partition 5. What this means, what is the difference in this case? The precision of the date time 2. So when I was saying that the engine is very picky about the data type and the precision, that is the example. The column that we have on our table, it has a date time to 0. If we pass a date time to 7, which means until the nanosecond, okay, precision, the engine will say, well, it's not safe for me saying that I can exclude some partitions because those values that I have does not match in the data type. Then let's scan the table. This is a small table, 5 partitions. Imagine this on a partition table that normally has dozens, hundreds of partitions, and that normally has millions and millions of records, okay? So the bottom line here is to avoid implicit conversions, like we saw on the first one, that the engine had to convert the Unicode to non-Unicode to be able to compare the data. And we saw how using the wrong data type for the partitioning column can lead to not having partitioning elimination, okay? Any question? A curiosity? Because of this, I work with one client that had an ETL process running for like 12 hours during the night, and I can tell you that 85% of the improvements went from 12 hours to 2 hours was due to the data type precision. So they had partitioning, they were reading data, they just need to read the yesterday data, but because they were using like date time 2 period or 0, instead of the 7, which was the data type on the table, right? It was doing huge amount of reads and taking a lot of CPU and a lot of time to run the stuff. So just by moving these, we went from reading the entire table to the yesterday partition, which was the intent in the end. Would I use explicit? Right? So let me see if I got it right. You have a variable and comparing with the column data type. Right. Right. Okay, so the question is, if I do myself an implicit conversion, right, and I use this data type to do as a datetime to 0, which is the data type on the table, if there will be or not the same improvements. If it is a variable, and you do that directly on your code, you do like cast this as datetime 0, I expect to have the same benefit, okay? But imagine that this is an inner join between two tables, and one table has datetime to 7, and the other table has datetime to 0, right? If you do the join and you need that date to do the join, you still will need to do the conversion of every single record to then do the comparison, okay? Right, next demo is about the parameter embedding optimization. So SQL Server does a lot of tricks that we kind of don't see to make queries simple and to help us to have a better performance in the end. With the parameter sniffing, anyone is not aware what parameter sniffing means? Okay, so you don't? Okay. So parameter sniffing happens when the engine needs to run a query. You have a variable, the variable has some values, and it tries to pick the value that you have on the variable to get the data. And if the next time you run, you have that value change, and let's pick the example of the dates. You were searching for 1 day, right? A range of 1 day. And that will compile a plan that will be optimal to get data for 1 day. If you then run the same store procedure and you pass the parameters, but you pass like 1 month, you have much more data. But because your query is parameterized with those parameters, you already have an execution plan, and that execution plan will be reused. However, reusing the same execution plan for 1 day of data may or may not be optimal for the 1 month or 1 year. Okay? So imagine, if you have fewer data, you may have like a index scan with some kilookups, but then if you have like much more data, you probably will have prefer to have index scan right away of the cluster index. And if that doesn't change, because you didn't recompile, you didn't have a new plan, that will make your query go much, much slower. In this case, a way that normally we can use to get rid of this situation is using the option recompile on the query level, okay? This will make the engine to sniff the parameter, get the value out, compile a plan with that value, and that will be much more precise compared with a random value, which is the compiled value that you had before. So let's say we have here a store procedure that just do a count of the number of posts, and it does based on a user ID that may or not be passed to the store procedure, and if not, it will just do for every single one. If it passes, it just do for a specific one. And let's say if I run this query, was fast, like less than 1 second. I forgot to turn on the execution plan. So the question is, I have this query. I run the query, and I did for a specific user, okay? And the engine decided to do a scan. Okay, so, and I have an index, because on this table you see that by the name is NCI, so non-cluster index, but it decided to do the scan instead of a seek. Why that happened? So the first tip here is here. So one of the demos I did on the Tuesday was related with dynamic reporting, that you can pass multiple parameters, just one, none, and build the query like this, that you append, and this variable is null, or the value is not null and have something, and another value, and so on and so on. What happens is that the engine, this way, just say, well, I compile a plan, you passed me 50, but I need to check if the parameter is null or not, so I will scan, period. Which means that if I get rid of the user ID is null, the engine then say, well, you know what you want just this user, you know this is the field that you want, let's do a seek and go and pick the data, okay? Let's see why this may be important. So a way to fix this, or to improve this, will be to append, in this case, this option recompile. Please pay attention that this is on the query level and not on the store procedure level. You can have a store procedure with 10 queries. You can put option recompile in specific queries, but you don't need to put on the store procedure. Otherwise, each time that you run the store procedure, it will recompile the entire thing, and not only those specific queries inside. And that can incur in a penalty on performance, because the CPU will be just being burned every single time to compile again. So what happens now, if I run exactly the same with the same value, we now got our, I would say, expected seek. Why that happened? Because the engine is our friend, and it just picked the query. He removed the extra work which is not needed, and you can see that the value 50 right now appears on the operator. So what it did with the option recompile, it recompiled, read the value inside of the parameter, replaced that value on the query, eliminated the parameter is not null because it's not, right? It's 50, and send this query to the engine to run. And therefore, we can now get a seek and be much more precise what we want to get. So far, so good? Make sense? Thank you. So let's say, for some reason, we work with other colleagues, we are developing code, there is a new need, and we need to change this store procedure. And we actually need this count that we are getting to be used later on our store procedure, because now we can get the data and do something else afterwards, okay? What you're gonna do? I will do this. I will create a variable, assign the value of the count to that variable, and afterwards do something with it. In this case, I'm just outputting, but I think you get the idea of this. What is the problem of this? The problem of this is that I still have the option recompile, right? Hello scan. So the optimized parameter embedding approach works great, does the thing that we just saw when we use the option recompile, which is eliminate duplicate work or things that doesn't make sense after reading the value of the variable, and or until we get to this example, local variables. Okay? So now imagine that you were doing this count with the option recompile you had there, because you know that this can be 50 today, another user do 100, and so on and so on and so on. Everything runs very fast, all things very good. You deploy a new version, you put this local variable approach because you need to later, and all of a sudden you go to query store, and this query will be like here in CPU and logical reads and all that stuff. What happened? Well, I just added a local variable, but that is how it works in this case. Okay, so be aware that using this approach doesn't make possible for the engine to use or to do the parameter embedding optimization. So what is the approach, or what is the option? So the idea here can be that you count the value and do it, put it inside of a temporary table, so not a local variable, but a temporary table, and then you get that value from the temporary table. And in this case, if we do that, hello seek again. Okay? So be aware, whenever you decide to pick variables, read from tables, or put in local variables, and then do something else, this may happen. Questions? Yes? Sure. To the current one or the previous one? So the comment was to scroll up to the... Yes. So the question was, is the receiving value that is causing the problem. So the problem is the embedding optimization works fine until you have, or use, in this case, the variable. Okay?
So if you're using local variables in your where clause, it wouldn't disable it. It's just because the variable is receiving the value of the count1 that's causing it to be disabled.
In this case, it's because you are getting this output to a variable. If you are using, as we are using, the owner user ID, right? On here, as I shown before, if you have the option to recompile, it just runs fine.
Yeah, so my question is, if you had an internal variable at the top, say, declare internal owner user ID, set the value to the external variable, and then put that in your where clause.
That can, okay. On that, you can incur in a different situation. If you are using local variables to get the value from the parameter of the store procedure and then use that variable on the query, be aware that local variables, the way the engine calculates how much records are estimated to be read, it differs. Okay, so the estimate records to be read, it differs. Hugo Cornelis had a session about estimates, so you may see that, or you can search online. You will find why local variables may have a problem. And by the way, this is a good point to do or to talk about an example. When we pick a query that is slow, is inside of store procedure, the normal approach will be copy that block outside declare the variable, put some values, right, and run it. And then, well, it's fast, or it's even slower. What happens? Be aware that you are not doing the same tests. You are not calling the store procedure that contains that query, and therefore use the value of the parameter, okay, to run. One suggestion, or at least the normal way I would go, I create a temporary store procedure, okay? I use the same structure of the store procedure, but as a temporary, to be able to call it from outside and to try to have the same behavior, okay? So local variables versus parameters is different things and can lead to different estimates, and therefore you can get slower or faster, depends on the situation.
Thank you.
No problem. I will have in the future a demo with that portion, like with the local variable versus a parameterized value in the end. Oh, we are on time. 35 minutes, right? Okay, so yeah, this last part is in case we want to run the 4 versions of it. So we have the original one that was doing the scan because it will not eliminate the OR variable is null. We have the second one that we put the recompile, and then we have a seek. So a scan, a seek here, and then a scan and a seek again. So with the difference that this one is having the value as a variable, and this one is having a value from, or is inserting on the temporary table and then read from that. Okay, so where I am here. Next demo. Who have seen or who have used queries like this? So joining two tables, and because you need to do, instead of and, you need to do or. So you need to join on one condition or a different condition. Anyone ever wrote something like that? Thank you, I'm not alone. Don't be shy, we are all humans. So what I want to show here, so I will put the query running, but because we have the party later tonight and I want to go there, I will stop it because it won't finish soon, okay? So what I want to show is like 11 seconds, 12 seconds, it's running, right? Let's see estimated execution plan. So this is the estimated execution plan. As I don't have any filter, I mean on specific tables, I'm doing a scan of the user tables using a non-cluster index, which is already a smaller one. And then we have a table spool, which the cluster index is reading the cluster index of the post table. A table spool is the engine try to helping us. Is the engine say, come on, you don't have an index on these columns that you are working, let me create that for you. And this table spool is a table that will live on the tempdb for the time that the query is running, and has like an internal index, in this case on the owner user ID. And what it will do is, so we don't have the actual execution plan, so here we cannot see. But what it will do is, I have user ID 1. Go to the post table, give me a user ID 1. It goes to the post table, get everything, ID user 1, put it there. Then we come with another one, user ID 1. I don't need to go to the table, I go to the table spool. I reread the data that the table spool already have. Next item, ID number 2. Is ID number 2 here? No, it doesn't. Clean this table, go to the post table, come back with the 2, and so on, and so on, and so on. So whenever you have these kind of patterns, and even if, because we sometimes have these and the tables are not very huge, and this just runs fast enough for us, still, keep this in mind, because as the tables will be growing, you probably won't remind that and won't come back and change, I don't know how many store procedures or queries running in this way. The idea here is to split, to conquer. So what we can say to the engine is, hey, I need this data of the combination between the post and the users, where the owner user ID is the ID, or if the last editor user ID is the account ID, and this query finished in 4 seconds. And I forgot to include, sorry, let's run again. So what we are saying is, do this work twice, but on different combinations. And by doing that, the engine split the work into, let's say, 2 branches, the top one and the bottom one. It does what it needs to do individually, concatenate the values, and come back. What you need to pay attention in this case, I'm using a union, because if I'm saying that I want one or other, actually I don't want duplicate values. If you do union all, you will get duplicate values, okay? So it's another small tip. But let me check. We can say, and one of the things we talked about was the compatibility level, right, of the database. Let me pick here one example just to show you. Actually, yeah. So if I'm not wrong, I was running this on 2016. I will run this on 2022. And I just want to double check if, yes, cool. So I just changed the compatibility level, and now I have completely different plan. So once again, when someone comes to you and say, hey, this query was very fast, we just switch on this thing, and now it's very slow. Or it's even faster, it depends, right? The thing is, what will you change? Did your DBA change anything? Is the compatibility level changed? Because now, what we see here is that we are using a new feature, which is the adaptive join. So on 2019, if I'm not wrong, adaptive join comes, and what it does is, dynamically, he have these possibilities, and it will decide depending on the run, and on the data and on the filters that you have. So your question would be probably, is that, or is this better because the batch mode adaptive joins is turned on? Could be, okay? But to prove that is not, I will turn off on this database. We can run again the union query. The plan will change, because now I said no adaptive joins to be used, please. But still, we have a good performance, so we have 4 seconds, okay? So be aware, all these small switch on and off may change completely the thing. Like, I'm using developer edition. If I was using a standard edition, I would not have batch mode execution, period. So once I was looking to a query, and for 1 hour, I was like, why are you not using batch execution? You have more than the 132,000 records that is needed and a couple more checkpoints. Why it's not running? Oh, which version I'm running? Standard. Okay, thank you. So it's a lot to have all together. I get that. It needs experience, time, banging with the head, and so on. How much time do we have? 5? Okay, so let me see. Let me show one thing first, and if we have time, I come back to this one. I want to show something that I also have shown on the last session. I will not go to the slides, but let's say I will zoom. So this is a decision tree. I will shortcut here. This is a decision tree. So the question is, some people say, hey, there is any magic button. Can I click here, do that, and so on? This will make everything faster. No, that does not exist. As we saw, different combinations, different stuff will make things go differently. So I start designing a decision tree to help you try to, after you find your slow query, you read the query, and if you answer a couple of questions, hopefully you get a couple of suggestions of things to try out. This is not a silver bullet. The suggestions here is not one size fits all. But at least you will say, oh, wait a second, let me test then the temporary variable. The temporary table. Or let me rewrite with the union instead of the or. Okay, so you will get these small hints to try on your scenarios, because the data that you have, how much data, how skewed your data is, everything will matter, okay? And sometimes one solution is very cool and is working right now, and then we get much more data, and all of a sudden it starts becoming slower. So be aware of that. And again, this is not the magic button, but take this as something that you, even if you are not tuning something, you just read it through this, and I can guarantee you that you will learn a couple of things. I learned a lot by doing this, because I did research, and I had to study and test it out and double-check if I could fix it that way or not. So think on this as a kind of a guideline that you can use. Just to give an example, I have the query, does it use CTEs or not? Common table expression. Let's say no. Are you using partition tables? Let's see, we have this example with the partition tables. Let's say yes. It is using the partition column to filter. So we have the partition column on the where, like we had before. Yes. Do you see the partition elimination happening? And for those that didn't know the partition elimination, your first step will be jump on Google, Bing, whatever, and say what partition elimination is, and you will learn something new today. And then let's say, no, it's not happening. And it says double check if the columns and the data type and the precision, okay, are the same. And if you fix that, do you see or not an improvement? And if you saw an improvement, you go here to the party moments, or to double check if you have improvements. Otherwise, in this case, I'm pointing to a Paul White blog, which talks about why the partition elimination not happening. And you can read a little bit more and try to understand on your scenario. Okay? So this is the kind of thing that you can get from this tree, which will be updated every now and then. And this is on my GitHub. So there is a repo called T-SQL Performance Tuning. The best way to keep up to date with this, if you start to follow, every time that I do like a new commit and I change something, you will get an email saying there is a new version or there is something that was added. Sometimes will be some typos that I'm fixing. Some other times will be an amount of new stuff to cover new scenarios. So here, about the thing, there is no map, there is no silver bullet, but there is this that hopefully you found interesting and to get something from it, which is here. And this recap is from the other one. Questions? Or if you don't, I can still try to show the last demo. Do you prefer that? 2 minutes? Yeah. Yes? Okay, last demo. Scalar functions. Who doesn't love scalar functions? I don't love twice. Twice. So, but we have new improvements. We have new features. We have inlineable scalar functions now. Does that mean that everything now runs faster when we have a scalar function that can be inlineable? Because they may not be inlineable? Nope. Sometimes not. But this is a different story. What we are seeing here is I have a function that will count, it will sum, the score that, what is the sum of a score based on the close date of some of the posts. And we go to that second version in a minute. And in this example, I will run on 130 version, so SQL Server 2016. And I have here the date 2 and the date 1, so this is the second version that will go there in a minute. Thank you. So the question is, I'm getting a top 10 parent ID and getting the score from the function, from the posts table. And when I run that, if it runs under 1 minute, come on. So while this is running, I will tell you. Oh, OK. There you have. So what happens here? First one took and 23 seconds. But I prefer this one. It's the same data, same outcome. Trust me, I'm a professional. However, what happened? And you may say, well, that happened because you were not using SQL 2019 with the inlining function, which again is a scoped configuration that you can turn on and off. By default is on, but you can turn off on the scoped configuration, and you can even keep it on and turn it off on the scalar function level. Okay. So if I say the 15 and I run again, I need 30 seconds. Thank you. If I run again, as you can see, it's not much better. It's still slow. 8 seconds, 1 millisecond. I still prefer the bottom one. What is the point here? For those that use scalar functions, be aware of this. This is something that is on the documentation, but who reads documentation? Come on. If you can say your scalar functions, if you receive a null value, and we have null values on the the close date. Okay, so I have close dates which have null values. What I'm saying to the engine, hey, you went there, I passed the null, don't do nothing and come on, let's go. But if I don't do that, I'm doing for every single row I have on my table, going here, try to do the sum, meaning scanning the post table based on that close date. I can have an index there, but to, in the end, finish and say, I have nothing to do, and let's go back 0. Okay? If you do that, you are avoiding this extra work per record. Okay? So that's it. Please, the feedback I appreciate. The charity appreciates too. Thank you for coming. Hope you enjoyed. See you next time. And if you have questions, I will be around, okay?